Hello and welcome to this video from University of Plymouth where I'm going to be talking about projects and dissertations that our students get involved in. So my name is Adam Kite. I'm a lecturer in here and I specialise in engineering design and also computational fluid dynamics. So we're going to be talking a little bit first of all about dissertations. So your dissertation is a big individual project that you'll do in the final year of your BEng or the penultimate year of your MEng degree. And it's where you get the chance to put together all the different skills and bits of knowledge, etc., that you've learnt in other modules, in other subjects throughout your degree. And in fact, if you have a look at our subject areas video, you'll see a little bit more about what's entailed in all those different subject areas. But this is the big individual project where you get a chance to really study something in a lot more depth, something that you're particularly interested and excited about. The first one we'll talk about here, Jake Cronk. As you'll see, if you look at our placement and careers video, Jake did his placement and then went on to work as a graduate in the Mercedes Formula One team. So that developed a strong interest in turbochargers. And Jake did his dissertation all about how we can modify the airflow going into a turbocharger to try and put some swirl into that airflow. And he did a load of calculations to try and work out performance efficiencies associated with putting little guide vanes here at the inlet to the compressor of the turbocharger. He then set up an experiment to validate those calculations. And finally came out with predictions and confirmation about the sort of performance increases that these vanes could give. A totally different sort of dissertation here. So Maria was interested in total knee replacement. So that's the artificial knees that can be put into people. And she was looking at how those were affected by different sort of sports and studied skiing, tennis and golf. So she used a finite element analysis model of a total knee replacement to try and work out how that would respond to the various different loads imposed by those sports. And surprisingly enough, actually, she found out that golf was probably the most demanding of those three sports, predicted how the thing was going to behave in golf, and that can help to actually improve the design of the total knee replacement and tailor it to the needs of a particular athlete. Another dissertation that's very different again. So William Fuller was interested in the motion of in this case, a marine mammal. So the flapping motion of the tail of an animal. And he came up with this idealized model of an animal that is propelled by a flapping tail. Which may look very simple, but is actually horrendously computationally demanding and difficult to get right. Now, fairly simple models can be run on a fairly standard university desktop machine, but for big simulations, we actually need to go to a high-performance computing cluster like the one you see in the middle picture there. And the reason we're interested in doing this kind of project is also aligned with some of our research work, where we've been looking at the impact of data loggers that tend to be attached to various different sorts of animals to gather information about their behavior or the environment, possibly even climate change, environmental conditions that they're in. Another dissertation here, Arlie Hill did a really interesting one about working out whether he could find a very low-cost alternative to the sort of equipment that we typically use for measuring forces. And he came up with this idea of manufacturing using a 3D printing machine, a shape like this. And this particular shape has got a very small gap at one end. And on the other end, he mounted a low-cost USB camera, and that camera is just looking at that gap there. He then wrote software to process the image that the camera was sending to deduce from that image how much force is being put on the top of this component. And he calibrated and tested that in our tensile testing machine. And he looked at material properties and possible failure of the device using a scanning electron microscope, and actually came out with a device that was extremely accurate and reliable for a fraction of the cost of a normal force measuring device. So that's some of the individual projects that students typically get involved with, and really the world's your oyster in terms of what sort of dissertation project you pick. But also our students get involved in group projects, working together, usually on big design projects. And we try and pick these design projects in order that they do draw on lots of our individual, the sort of subject areas that we talk about in the subject area video. And we use these projects as examples within those subject areas. The first one I'd like to talk about is the human-powered submarine. This is something that we've had lots of students involved in over the years. It sounds quite crazy because it is absolutely crazy. So it's a flooded submarine. So it's powered by an athlete who's breathing using scuba gear. The submarine was designed, built and raced by our students. And the first time we competed was in 2014 in the UK, coming a very respectable 3rd out of 10. Which we were actually really pleased with, considering the team that won, I think they were from Canada, and they'd had multiple attempts, many years of submarine design and racing experience. So we were really pleased with that. The next time we competed in the USA the following year, our students had made quite a lot of more high-tech adjustments to the submarine design, and actually discovered one of the golden rules of design, that keeping it simple is often one of the best ideas. So some of those control systems didn't work quite as well as planned. And actually, although that submarine wasn't quite so successful in that competition, I still maintain that our students learnt a lot more from the submarine that didn't go so well compared to the one that was very successful. Second thing that I'd like to talk about, second project, has been ongoing for a few years with our students. A hand cycle, and as the name suggests, it's like a bike, but powered by arms rather than legs, usually by disabled athletes. So here's the athlete that was working with us there, Sarah Piercy, who has limited use of her legs. So the hand cycle was built, designed and built by our students and staff. And we had world record attempts out in Nevada, both in 2015 and 2016. And we finally managed to get a new world record in 2016. Now this was a great project because it was initially a second-year design project where teams were working on different hand cycle designs. And again, keen students went on to build designs in their third year, but also other modules such as composites modules. We're looking at materials behavior in the hand cycle, computational fluid modules in the MEng year. We're looking at the aerodynamics of the thing. And in total, we think about 500 students had some form of involvement with hand cycle design. So a really great fun project for students to get their teeth into and put their engineering skills and knowledge into practice. Hopefully that's given you a bit of a flavour of some of the dissertations and projects that students get involved in here at Plymouth. If you have any more queries, please do have a look on our website, and if you want to get in touch with us, the admissions inquiries details are there. Please do get in touch. Thank you very much for listening.
Hello and welcome to the University of Plymouth. My name is Richard Pemberton and I'm one of your lecturers here in Mechanical and Marine Engineering Design. One of the things that really motivates us as staff here is to help students go on and get that dream job that they've always wanted. One of our students, Michael Prest, he was able to do that by doing something that we really encourage on the course, and that's taking advantage of our placement year scheme. Between the second year of study and the third year of study, there's the opportunity to work with a company for a year in a paid job, and the university will support you in doing that. We've got a full-time member of staff who liaises with companies and goes out and collates the job adverts and supports you in terms of developing your CV so that you can get that foot in the door with the company at an early stage. And the placement year has been very successful in terms of converting placement jobs into full-time jobs at the end of their degree programs. When I asked a group of students 18 out of 20 had been offered full-time employment by their placement company. Where do our students end up going? Well, they end up going all over the world. We've had students like Michael going to Formula One companies such as Red Bull Racing. We've had them go into the aircraft industry in Bristol area such as Airbus. Further afield in Holland, we've had students working in Vitter's shipyard, and close to home in Plymouth, we have a number of students regularly go to Babcock at Devonport Dockyard. We've had students go to the turbine manufacturer, Rolls-Royce, and also on the marine surveying side, Fugro Seacorp down in Falmouth. Some of the examples of our students are as follows. One of our students, Jake Cronk, ended up spending a year at Mercedes, and he's since gone on to get a full-time job there. And one of the things that he felt was really great about his placement, that was from day one, they treated him as a trusted employee and let him get on with tasks just like all the other members of staff, including Lewis Hamilton. Temi Danso had a slightly different placement in terms of how it was broken up. She was working at Jaguar Land Rover and had 5 mini placements, getting to see a wide range across the whole company. She found it a very positive experience, and like many of our students, she found that it allowed her to improve those skills that are key to employability, not just her technical skills. It's not just the car industry that our students end up going into. One of our students, Joe Malloy, he had his placement year at the South Devon Railway, and he's since gone on to work there too in a full-time position. And he's really benefited from the people who he met there and that support network that he built up in his placement year. And he, like many of our students, wished to continue on beyond that, just the year. Your lecturers also come with a large amount of industrial experience, and we're always keen to bring this into our teaching. One of your lecturers, Adam Kite, is currently undertaking research into the numerical modelling in reconstructive surgery. There's Adam practicing on sewing micro arteries together. Don't worry, it wasn't a human, it was with a chicken leg. And this is really important in terms of surgeons being able to sew skin grafts back into a victim of cancer or a motorbike accident or the like, and being able to make sure that the blood flow is continuous and you don't end up with clotting problems or the like. It's very difficult doing tests on real people, and generally surgeons want to avoid doing animal testing. So Adam's looking in using his engineering skills in numerical modelling to support the surgeons in terms of discovering better ways of sewing arteries together. In my own career, I've been very fortunate in that studying engineering has allowed me to work within my passion, which was sailing. This boat that we can see on the left of the picture is a boat called Vestas Sail Rocket, and it was the precursor to the boat you can see in the video on the right, which Vestas Sail Rocket 2, which broke the world speed sailing record at 65.45 knots. I was a member of the design team of the first boat and involved in the early stages of the second boat, and there it is down in Namibia breaking the record. I learnt a great deal out of doing projects such as this. They formed the basis of my career as I moved on, and I look to inspire other people to be able to do similar projects as this. It wasn't just a fun project. The main sponsor of the project, Vestas, was keen to see how we could develop numerical tools and keen to see how we could use materials that it would use in its wind turbine business. These are some of the highlights our lecturers have had in our careers, but what we look to do at Plymouth with our degrees is to give you the possibility to solve some of the problems that society will have to address in the future. For example, power generation. How can we do this in a clean, environmentally friendly manner? Or urban transport. How can we do that where it impacts our cities less? If you'd like to contact us, please do so through the admissions email or through the number provided. Thank you, and we look forward to hearing from you.